Good morning to all. I am Kiran Pachlasia, Assistant Professor at Sagar Institute of Research and Technology, Bhopal, the SAGE Group. Today we are going to discuss on subject theory of computation, where we are going to discuss about grammar. Topic for discussion: what are grammars? How grammars are used in automata? Grammar constituents, example of grammars, types of grammar in which equivalent. Today we are going to properly execute equivalent grammar. What are equivalent grammar, ambiguous grammar, unambiguous grammar? So we are starting from grammar in automata. What do you mean by grammar? Grammar means the basic structure of the rules which are used to generate any string. A finite set of formal rules that are generating syntactically correct sentence, or in easy way we can say that if G is a grammar which consists of set of all production rules, it is used to generate the string of a language. A grammar consists of 4 tuples VTPS, where V stands for finite non-empty set or non-terminal symbol. T stands for finite set of terminal symbol. P stands for non-empty set of production rules, and S stands for starting symbols. Grammar constituents mainly two: terminal symbols and non-terminal symbols. Terminal symbols are those which are the constituent of the sentence generated using a grammar. Terminal symbols are denoted by using small case letters such as small a, small b, small c, 0 or 1, etc. Non-terminal symbols. Non-terminal symbols are those which take part in generation of the sentence but are not part of it. Non-terminal symbols are also called as auxiliary symbols or variables. Non-terminal symbols are denoted by using letters such as capital letter A, B, C, etc. Some examples of grammar. Example number 1. If S is a production, S representing small a, capital S, small b, capital S. Similarly, second S producing small b, capital S, small a, capital S, and S also producing epsilon. So what do you mean by this? These are called as production. Whenever a question is given, so this is known as production. Capital S is known as variable. Small a and small b are known as terminals. And because S is a starting symbol, so we have S as an starting symbol. So V representing S, non-terminal symbol, T representing small a and small b as terminal symbol, P whole production, every production of S is representing as production, and because S is starting, so it is known as starting symbol. So what it is creating? It is creating equal number of A's and B. How? When S is taken as A and S is put here, we can put here epsilon. So we are having a single A and a single B. If S is representing S is representing S, B, S, A, S, then we have gotten double A and double B. So this production generates equal number of A's and equal number of B. In second example, what is the production? Productions are these. These are the productions. Variable are capital S, capital A, capital B. Terminals are small a and small b. Starting symbol is capital S. Types of grammar. Grammar are basically divided in three parts on basis of production rule, on basis of number of derivation tree, and third one on basis of number of string. So we are starting from on basis of number of derivation tree, in which first we move on ambiguous grammar, then we learned about unambiguous grammar. One more term is come in grammar are equivalence grammar. So what are equivalent grammar? Two grammars are said to be equivalent if they generate the same language. For example, if we are taking grammar G1, what is this production? S produces A, capital S, B or epsilon, means this grammar generating AB, number of A equal to number of B. Second number of grammar 2, G2 is S produces small a, capital A, B or epsilon, and A produces small a, capital A, B oblique epsilon. Means this production and the grammar 1 production are generating the similar strings. So both grammars are generating the same string. So the language of this grammar should be A to the power n, means number of n is equal to number of b's, so that the grammar G1 is equal to grammar G2. This type of grammar is known as equivalent grammar. Now we are moving on the number of derivation tree grammar classification. Types of grammar we are showing in the form of derivation tree. First is ambiguous grammar, second is unambiguous grammar. In ambiguous grammar, a grammar is ambiguous for any string generated by it produce more than one parse tree or derivation tree or syntax tree or leftmost derivation tree, rightmost derivation. If any possibility come in the grammar is ambiguous. For example, we are considering this is our grammar. E produces E plus T, E produces E multiplied by E, and E produces ID. First, draw the parse tree for the string. When we are drawing the parse tree, we are having more than one parse tree. First parse tree, when we take E plus E, from the leftmost E, we are having ID. From rightmost, we produce E multiplied by E, and the E at last produce what? ID and ID. Similarly, if we are having the leftmost E with E plus E, we are having the same different kind of string from two different tree. If we having two different kind of string from same grammar, this type of grammar are known as ambiguous grammar. Since two parse tree exist for string, therefore the grammar is ambiguous. Similarly, when we are taking two syntax tree for this ID, we are having two different syntax tree. So thus this grammar is ambiguous, because we are having for same string we are having two syntax tree. Reason number 3, if we are having reason number 1 that there are more than one parse tree. Reason number 2, if we are having more than two syntax tree. Reason number 3, when we are driving from leftmost derivation, the string are having two string leftmost derivation two leftmost derivation or we are having two rightmost derivation, then the grammar is ambiguous. Now, when we switch to unambiguous grammar, so unambiguous grammar says that a grammar for every string generated by it, it is produce exactly one parse tree, one derivation tree, one syntax tree, one most left derivation, one most left right derivation. These type of grammar are useful in our automata. In the next video, we discuss leftmost derivation and rightmost derivation. Till then, stay tuned. Thank you.